What's up? Are we all awake yet? End of the conference. Had a huge party last night. I heard that bass thumping like 3 blocks away. You all hear that? It's a lot of fun. I have about 20 minutes, which is about the limit of attention. And I thought what I would do is talk to you a bit about the fundamentals, the technological fundamentals of how a lot of this AI stuff works. And I thought that'd be interesting because everyone's trying to do AI here, right? And I wanted to talk just maybe for a few minutes about some of the things that I've been doing along with my team to kind of improve that, use it, do it in a different way, apply it to business data in particular. All right, so we've all used these LLMs, right? And you go and you type something in like, oh, give me a 4-day itinerary, it spits out some stuff. We all know how this works. Been a few years, took the world by storm, all sorts of fun stuff like that. Now, fundamentally, the architecture of this is really simple, which is why so many people can use it, right? Because what you do is you go to some cloud service with some dude that's got a gigantic model that spent, umpteen $1 million going to make it, training it on public data, right? Very straightforward. We all kind of get how this works these days. Now, the thing that I want you to think about is how do you get a better answer? The vast majority of times when you want a better answer out of one of these things, and this has been true for years and actually forever, is you simply tell it more stuff, right? So if before I just asked, oh, give me this itinerary, and now you say, give me this itinerary, but I'm really afraid of reptiles, it will do better, right? And the more things that you tell it, the better the answer will be. And who doesn't want a better answer, right? Everyone wants a better answer. Can you imagine going and asking, your research assistant, hey, tell me X, and then they give you, an answer that's half as good as, that doesn't make sense, right? How does the research assistant get a better answer? Well, they go and they pull in more sources, right? And the interesting thing about this is that over time, the amount of sources that you can throw into this has dramatically increased, right? To the point where it's actually decreased. So at some point we realized that if you keep on stuffing more stuff in, you don't actually get better answers, right? There's a diminishing returns. Instead, you have to start thinking about other ways to kind of make your best answer. And so we went from something where you can put like 7 or 8 pages of text. You can figure about 700 tokens is like a page of text, right? Maybe under 1,000 tokens, like make the math easy, right? To something put like 100 pages of text, to something like 1,000 pages of text. And what we settled on is like a few hundred pages of text. Take a few hundred pages of text, you throw it in there, and you're kind of good. But there's other tricks that go with this, specifically, how do you get that stuff? Because in the example I showed there, right, for the Outback, I want you to give me an itinerary for a vacation. Do you want to go and tell this computer every last detail about your life so that way it comes up with a good itinerary? Ideally, it would know, but then that fundamentally has a problem too. Do you want the whole universe to know that you're really afraid of spiders, or that you're afraid of heights, or that you have a particular medical malady that prevents you from being able to do certain things, right? And so this concept that you can just go put that information in is not really a good one. So what we do these days, right, this is a standard technique, it's called RAG, if you haven't heard of it, is you read the user input, you analyze it, and then you think about what the hell the person said. And then once you've done that, you go and you take a look at what are the set of possible contexts for that. The good news about this is that we're really good at this. We have spent the entire internet age, essentially starting since 1999, 2000 until now, making ourselves exceptional at taking a free-form something or other and identifying a whole pile of stuff that's related to that. And so what do? We download that, hence the retrieve. We go and take that and stuff that into the prompt, hence the augment, right? And then we use that to generate. Now there's a few steps here that I'm kind of glossing over. In particular, the augment is not quite as simple as it would seem. Because if what I were to do is the simplest thing, which is what this appears to do, right? So when I use ChatGPT and I hit that button that says search, right? It says searching the web, and then it goes and it starts doing things, right? It would appear to me that what it did was it just grabbed a bunch of stuff and it stuffed it into the context. Because remember, it's like 100,000 or more, possibly 1 million. So this stuff is going now, and you can see that it's got those things that it searched and found, right? And so it seemed to me that all I had to do was grab that stuff and throw it in. It turns out that's not really quite true. Because when you do that, you don't necessarily get the best pieces of those documents. When you go and you pull all these documents, never every piece of it is relevant. And in some cases, not only is not every piece of it relevant, it's sometimes very hard to find that. Computers are exceptionally good at dealing with structured data. How do we know this? Because every single project manager you've ever run into makes everything happen on spreadsheets. Before we have entered into ServiceNow in some CRM, SFDC, something or other, it all started with some project manager entering it into a spreadsheet. And then by entering it into the spreadsheet, the computer can deal with it, right? And so this concept of structured data is incredibly important, because when I use this simple architecture of just going to search stuff, and then that's going to go and grab some public data, and then I throw it in there, the computer has a very strong tendency to vomit, which sometimes we call hallucinate, right? And so what's going on is we actually want to improve on this, and this is the current state of the art. Eventually I'll get to what I really want to talk about, but I kind of wanted to just tell you a bit the state of the art. State of the art involves doing stuff like this. So if the text has something like this, computers are kind of not so good at dealing with this. They're much better at dealing with this. So the question is, how do I get from this to this? Well, when you have a hammer, everything looks like a nail, right? So I go and I take the thing that I started with, and I ask it to turn it into structured content. And I hit enter. And you can try this experiment yourself, right? And it will go and will do this. And surprisingly, when you ask it to do this, or maybe unsurprisingly, because it's a very controlled example, the amount of vomit that comes out, the amount of hallucination that comes out is extraordinarily small. And when you combine that into the entire architecture, that's how you end up with the current state of the art, right? So you heard with all the keynotes and whatever, reasoning, blah, 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 blah. Let me simplify this if you don't do this stuff, you're not into the tech. Reasoning is basically 2 or 3 things that are very important. One is you run the model more than once. Because originally what we were doing with ChatGPT 2-3 years ago is you ask a question, it's a one shot, right? One shot, comes with an answer. Reasoning, you do it a lot of times. Second thing is that one of the keys about running it a lot of times is asking it to pre-process the data. So you go and you find all these things, you download them, and you ask the computer to structure it for you. And by asking it to structure it for you, that unstructured data becomes useful in very interesting ways, and then you can add it to improve the context, and hence improve the output. So the architecture is still very similar, right? You still have the search engine, you still have this thing, but you're doing this a lot of times. Now, obviously, you want to improve the model itself and whatever, right? And you can't really do this with a model that's got a tiny context, so there's a lot of things that have made this happen and gotten better over time. But the truth of the matter is that it's wonderful to go and look at the fundamentals of what's going on. Because when you look at those fundamentals, this stuff is incredibly simple. An LLM itself, also, if you want to understand it fundamentally, right, is just doing math, right? It's just multiplying and adding a lot of times. And then deep research is just running that multiply and add on itself a very large number of times. The interesting thing here, of course, is that you know how they like to say that if you do the same thing again and you expect a different result, you're insane, right? Well, in this case, you actually do, because think about this, right? I'm using the same thing and running itself, and by running itself 7 times, I get a better result than running it once. Kind of weird, but very true, because each time we're running it at a more isolated set of inputs. And that's another thing that if you play with these things and if you experiment it, you'll know. You'll screw around with it and you know. When you ask it a more isolated question, it's more likely to get it right. Less vomit, less hallucination, right? And so what we're doing here is we're simply automating the process of running it over and over and over again with smaller and smaller and smaller questions. And then we're combining that to get the output. That's how this works. Okay, so one of the things that I've been messing around with, and I'm sure a lot of people are, right, is how do I apply this to my business data, right? Because it's really cool that I can get this itinerary for my Outback thing, but really what I want to know is how can I make money with this? And so you could make money with this by selling this stuff, obviously, but I want to make money with this by using this, right? I run a business, and I want to use this to maximize my profit. Well, there's a little problem with this. The stuff that I was showing you before, talk to me about a 4-week Outback vacation. How often does the data set that produces that change? I wouldn't say very often, right? How big is that data set? Fairly limited. But you could imagine that the set of all human knowledge is large, but just cherry pick the things that people are willing to understand. How much control over who can see which subset of that information is there? Not at all, right? So where these LLMs are very good is when you don't care who has access to which part. The data set is kind of constricted to something which you can process with what we've got, whatever GPUs you have, and it never changes. Because what happens when that data changes using the classical LLM model? Well, they talk about these things, right? Fine-tuning, making new models, and buying, a gazillion GPUs to do that. It's very expensive, right? And so this being the key set of problems, how do I go and I deal with my business data? Because my business data, let me tell you, it is continuously changing. What is the simplest form of business data continuously changing? Every single time I sell something, my ERP has a new invoice. Hopefully I'm selling things often, because if I'm not, I don't know why I'm in business. And so if I'm selling something every hour even, or every minute, or hopefully several times a second, I got a problem. Because I can't just be, doing this with a continuously changing data set. Data is obviously going to be bigger because you want the set of things you're doing that, and more importantly, there's also complex controls. Who can see my invoices? Well, probably not everyone in the company, or maybe so, maybe not. But then not just the invoices, there's other aspects of it, right? Especially if I've got regulations involved, medicine, finance, stuff like that, HIPAA, Gramm-Leach, blah, 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 right? So there's all of these kinds of things that make it so that if I just take my data set and I slam it into this, I'm going to be in a world of hurt. So you got to understand that what's going on is that there's a bunch of questions that you can ask that are easy, and then there are ones that are hard. And traditionally, we measure this in terms of time, because in a retrieval-based computer, before we really talk about generated stuff, the bigger the data set I'm trying to look over and retrieve, well, then the longer it's going to take. Nowadays, we measure this often in kilowatts because, well, GPUs burn a lot of energy, right? So in the simple case of my business data, I want to ask something very simple like, how many widgets are in a warehouse? That's very easy. It doesn't really take much to do that at all. Instantaneous, right? If I want to report on that, however, that's a different story. That's obviously more complicated. And you can think about this spectrum of things, right? And obviously, when you go through this spectrum of things, the GPU type stuff ends up on the right. Another thing I want you to think about is, remember what I said about turning that unstructured data into structured data? That's a relatively cheap operation. It turns out that it is not completely linear. In other words, if I were to take that big piece of data and I were to just slam it through once, it's actually a lot harder than cutting that piece of data into 100 things, running it 100 times, and running a summarization. So that simple optimization makes a huge difference here, and that is why there's this spectrum of GPUs you can buy. Because the ones on the left, the smalls and the mediums, those can do those simple things. The ones on the right is what you need to go and do very complicated things. We are all truly enamored with the LLM's ability to answer a question like this. Write a 6-page essay on the human condition in style of Nietzsche. I want you to think about how often I do that with my business data. Do I walk up to my ERP and ask my LLM to express the results of my ERP as a Freudian analysis in the style of Shakespeare? I mean, I guess if I was crazy, I could, or maybe if I'm running some kind of marketing thing. But for the most part, these very complicated things which capture our imagination with LLMs, They are not the things that we do. And so the question I ask is, why do we prepare to do this with every fiber of our being? If you take a look at the vast majority of architectures out there for dealing with business data, it looks something like this, which is crazy. I ask my data custodian, CISSP number 48597, to please give me a copy entirely of all of my proprietary data and send it to the cloud. Keep it up to date while my proprietary application updates this, and then I'm going to go run the biggest GPUs on the planet to go and prepare myself to express that data in the style of Shakespeare. So when I say this and I think about what I've just said, I'm like, that's just insane. What I really want to know is why everyone is doing this. Because this, I'm not kidding, in case you haven't tried this yourself, is actually the de facto standard. You walk down University Avenue in Palo Alto, and within 5 seconds, you will trip over some dude that just got $5 million from a VC to build a thin wrapper on top of a cloud thing that does this. And there are thousands of them. This is what we do. And it doesn't make any sense because it doesn't align with the way that we use it. I will say, however, it does align with making a lot of money if you're on this end of it, right? What are the questions we actually like to ask? Well, it's not about generating things in the style of Shakespeare. It's like, tell me about my inventory. Or in very complicated versions of it, it would be about, can you automatically tell me what I should do with my business? Give me some strategy. That'd probably be the most complicated thing. And in the end, this is actually still just running a report. So with this massive data set I got to mess with this continuously changing data set, with these proprietary controls that I'm asking mostly simple questions with only an occasional hard question, I wonder why we do this. And I think the answer is we should not. And certain people that run keynotes at this conference have pointed this out. Last year, we agreed inferencing is cheaper on-prem. This year, 85% moving on-prem. I'm a nobody. He's a somebody. These are his words. Right? So people agree that they should do this. We have the hardware solutions to do this. What is bizarre to me is why no one out there is out there screaming at people as to what the actual software architecture you should use to accomplish this should be. Instead, we spend $1 trillion on venture capital to do silly things. So this is my version of how to deal with this. You have this proprietary data, so step one is you don't want to lose control of it. So you put a server on-prem with the GPU on-prem, and the phrase from this year's keynote was, move the AI to the data, right? That was the phrase, the big phrase. Move the AI to data. Said it like 10 times. Well, the technical expression of that would be to install a server on the prem with the GPU and put the data on there. But there's a little problem with just doing that. Remember about 5 minutes ago, I was telling you about what's the problem with this? If you just take this data and you slam it in there, well, first of all, you probably run out of context. But then if you don't run out of context, you run into the problem that it's not going to be a very clear way for you to go and do the processing that you want. You actually need to pre-process this data into something that is consumable by the LLM efficiently. And that, there's well understood pieces of technology to do that, a lot of open source that does that, fancy words, vector search, text embeddings, that kind of stuff. The interesting thing, though, is that you want to keep it on-prem, you want to do the pre-processing, and as a result of the pre-processing, you can make very efficient forms of reasoning that don't take 7 minutes. And by doing this, right, we maintain the data set security because it's on on-prem. Proprietary controls can clearly pass through that. The congruence is there because we don't have to go and copy 47 terabytes every hour to the cloud. And the structure, of course, is taken care of by the fact that when we do that copying, we automatically structure it. So this kind of takes care of those problems. and it's about 100 times cheaper, right, or more. In our experiments, we use Dell XR7620s with NVIDIA L40S GPUs, and the screenshots I'm going to show you all come from a system that does that. To scale this up, well, you go put more XRs out there, you put more L40s, and then we kind of do a distributed manager for that. If you want to see some of this stuff, come to our booth. So with this architecture here, I want to show you what this actually looks like in our software. So let's say you have a bunch of PDFs. Let's start with the simplest case. You have a whole bunch of PDFs that represent your data, right? Let's not go to, the ERP just yet. That'll be my next example. In the simplest case, I have static data. In this case, like it's, information about an airport, menus, stuff like that. So I copy all this stuff in, and these are automatically generated. And what that does is it caches the ability for you to search this stuff. Your data starts looking like this, just PDFs, no trickery, right? And these are actual screenshots of an actual working system, not strange PowerPoint stuff, and this is an actual result. I can ask this chatbot, where can I find breakfast at the airport? Now, if I were to ask ChatGPT, where can I find breakfast at the airport, would I get a reasonable answer that knows which airport I'm at? No, because ChatGPT is going to give you a generic answer based on what it's trained on. Here, because we've loaded that data, you don't have to specify the context ahead of time. Remember my Outback 4-week vacation thing, right? I had to give it information. I don't like reptiles. I'm afraid of it. Here, if I were to do this, I'd have to give it that information at the prompt, but because I preloaded all of this, I don't have to do that. And this will tell you exactly what our good options are, including what time they open, because it pulled that data in automatically. I can ask a follow-up question. Do any of them serve oatmeal? Can you imagine asking that follow-up question to a Bing or a ChatGPT? You would get hallucinative, vomited garbage. But in this case, we get exactly what's going on. It's gone and figured out that indeed there is exactly one place that does this, right? So this is what I believe is an architecture that is wonderful for business data. It's not as good, obviously, for dealing with general answers, but for business data, it's absolutely lovely. And you get great results. So here you go. With this architecture, what can I do to expand this? Because remember what I said. What I said was that we're going to go and load this data, right? We're going to load this data. We're going to run the embeddings, and you saw the result. What about my invoices or other things in my CRM or other things in my ERP? That requires more sophistication. One of the things that we decided to do with our particular AI platform is we decided to make it so that it could run API requests and run HTML requests and download things and then cache the result of that and refresh that when the query is asked. So if you think about the invoice thing, this would be like telling the LLM that when you have any question that has to deal with invoices, go here and refresh this in real time. Not using the invoices I know. Go get new ones. And that's what this screenshot shows. This is actual configuration of an actual working thing. And the result of that is something that looks like this, where I can ask it a question about, for example, a flight, and this will go and grab it in real time. So this is an actual screenshot, asks for a departure gate, and the LLM knows what this means, and it goes and hits the API and grabs the relevant data. In fact, it grabs more than it usually, automatically structures that, loads that as JSON, prompt engineers it, and then spits out a reasonable answer. So this, I want you to keep in mind, has no cloud, no crazy, insane, massive, multi-million-dollar thing. It's completely on-prem. In this demo, it happens to be on a $10,000 server, but we could do this on a $2,000 server. Your data stays in place. Your data can change as much as it wants, and this will always give you an accurate answer. Here's another example. So instead of hooking that up to the thing for the airport thing, this is for like a stock quote thing, right? So we hooked it up to the API of the stock quote thing. Now, normally, of course, what you'd have to do if you're going to hook this up to a stock quote thing is you'd have to go and rerun those embeddings every time. We skip that step. We have the understanding of what one of them is as a sample. We reload that, and now when I ask for a quote, stock quote, it can go and it can analyze that output. So imagine how powerful this is, once again, with your data on your prem, right? So this architecture we think is particularly interesting. And here is kind of where we have gotten to. I'll leave it with this. Actually, the one after this. We've gotten it to a place where not only can we ingest data from an API, we can ingest this from almost anything you could imagine. And in this example, we've hooked it up to a thing which records the location of every device on the network at all times. So we have this ginormous data set that's continuously changing with continuously changing roles of who can access it. We isolate those roles to those pieces and feed it, and you can get a pretty sophisticated answer. And with just a tiny bit of prompt engineering, you can get this. So this is continuously changing data, unbelievably large, with security role-based access control, no cloud, on your prem, on this demo, less than $10,000 of hardware. I believe that this architecture I presented represents a radical transformation in the way that we can do AI. If you'd like to hear more about this, come to our booth. Thank you for your attention.